Assalamualaikum and hello to all. Today we are going to study chapter 4, Benzene. Okay, 4.1 Introduction and 4.2 Nomenclature. At the end of this topic, you should be able to describe aromaticity, which include all these characteristics, identify the aromatic compound, and also 4.2 Nomenclature, or naming the structure. Okay, what is drawn to you is benzene. So what is benzene? Aromatic compound is an organic compound that contains benzene ring. Okay, so benzene ring here, if it exists, so it means the compound is aromatic, also known as arene. And the molecular formula for this one is C6H6. Okay, C6H6 because it contains 6 carbon. 1, 2, 3, 4, 5, 6 carbon. Huh? Okay, and the structure here, this structure is actually Kekule structure. Okay, as you can see from here, the electron, this is the electron, the electron can be delocalized. It can move around. Okay, it can move around. It can move around. And when it move around, it can form this another Kekule structure, which can also move around. So in the end, you can draw the structure like this, which is also valid for benzene ring. So benzene is actually the resonance hybrid. Okay, this is resonance hybrid. Resonance hybrid between these two structures. And for it to become aromatic compound, it must be cyclic. Cyclic means it's a ring structure. So benzene is correct. So it is ring structure. Planar means it is flat. Completely conjugated. Okay, completely conjugated is referring to, if we draw in Kekule structure, okay, it means that the double bond, single bond, double bond, single bond. Okay. Okay, so double bond and then single bond. Okay, double bond, single bond, double bond, single bond. So this is what we call completely conjugated. And obey Huckel's rules. Okay, Huckel's rules refers to the number of pi electron. Okay, the number of pi electron. Okay, what does it mean? For one double bond, there are 2 pi electron. Okay, say there are 2 pi electron here, and there are also 2 pi electron here, and there are also 2 pi electron here. So if you add up all this number of pi electron, it will be 6 pi electron, right? Okay, 6 pi electron for this benzene structure. And it must fit this statement. Okay, when you have 6 pi electron, okay, 6 pi electron, for the formula for n plus 2, okay, you need to get 6. You need to get 6 pi electron. So n is actually 1. So 4 times 1 plus 2 equals to 6 pi. So it is valid. Okay, one more example. Let's say I have this structure. Okay, this structure. Okay, whereby you have 2 pi electron and 2 pi electron here, which is 4. Okay, 4 pi electron. So does it obey Huckel's rule? So 4n plus 2, 4n plus 2. Okay, if n equals to 1, when n equals to 1, this one will be 6, right? So when n equals to 0, 4n, 4 times 0 plus 2 equals to 2 pi, right? So when you have 4 pi, there are no number that valid with this formula, Huckel's rule. So that's why it cannot, this one is not considered benzene. This is not considered aromatic. This structure is not aromatic. It must fit all the statement. Okay, it must be cyclic, it must be planar, it must be completely conjugated, it must follow Huckel's rules, and then we can consider this as benzene ring. Aromatic compound, sorry. And that is the resonance structure. The 6 pi electron, which I explained earlier that it can move around, it means that it can completely delocalize. Delocalize means it is not at one local part. It can move around. Okay, naming, nomenclature. So now we are going to naming. Mono substituted benzene means benzene with one substituent. Okay, so you have benzene ring. This is benzene, and you have one substituent, which is chlorine. So the name for this compound is chlorobenzene. This is the prefix. Okay, this is the prefix. Chlorobenzene. Okay, benzene is the parent name. Bromobenzene. And this thing is nitro. So, nitrobenzene. And this one is ethyl. One substituent only, and this is ethyl. So, it will become ethylbenzene. This one is methyl. So, it will become methylbenzene. Or the common name, which is also accepted as IUPAC, toluene. Toluene. And this one actually hydroxy. This one actually hydroxybenzene. But there is a special name for this one. Phenol. Okay, when you see OH attached with benzene ring, it is actually phenol. Okay, next one. What about this one? Okay, you have COOH. This is actually the functional group for carboxylic acid. And there is a specific name for this one, which is benzoic acid. Okay, benzene carboxylic acid or benzoic acid. And this one, aminobenzene, because this is amino. Or you can also call it aniline, which is accepted as IUPAC. This one a little bit special. The third one is special. This is acetophenol. Okay, you can call it acetophenol. Just remember this name. Acetophenol. The other name for it is phenylethanol. And this one is actually aldehyde. The structure for this one is actually referring to aldehyde. So it can be benzaldehyde. Okay, that is the name that is accepted as IUPAC. Okay, now let's see disubstituted benzene. Okay, disubstituted benzene means it have two substituent at the benzene ring. Okay, let's see this structure. Okay, so this structure, if we try to name it normally, this will be 1, 2, bromobenzene. Okay. Okay, if you want to use ortho, you can name it ortho dibromobenzene. Okay, ortho dibromobenzene. This is refers to position number 2, this is position number 3, and position number 4. But only for disubstituted benzene. Okay, let's see the reunion. 1,2-dibromobenzene or ortho dibromobenzene. Okay, next one, the same thing. Okay, this is at position number 1, number 2, number 3. So this will be 1,3-dibromobenzene, or you can name it meta dibromobenzene. Okay, meta dibromobenzene. And this one will be para 1,4-dibromobenzene or para dibromobenzene. That is the name that you can give to this structure. Okay, the same thing for this one. Okay, you can just look at it. Okay, so this is the same. Substituent that is the same. Nitro, nitro, methyl, methyl, nitro, nitro. Okay, so what if different? Okay, what if two different substituent present? So you need to give the higher priority as the parent chain and number it at carbon number 1. Okay, so this is the priority. Let's say you have two substituents. Okay, let's say you have two substituents, NH2 and carboxylic acid. Okay, what I mean is that if you have benzene ring and there are two substituents, one is, let's say, NH2, one is COOH. So the highest priority will be the parent chain. So you need to choose this one as the parent chain, COOH, parent chain. And label carbon number 1. So this carbon label at the ring carbon number 1. Okay, so this is carbon number 2. Okay, so let's see the naming example. Okay, almost the same for this one. So the parent chain is this one. I hope you still remember when there is carboxylic acid, that one will be benzoic acid. Okay, benzoic acid. And this is nitro attached at carbon number 2. So 2 nitro benzoic acid. Okay, higher priority. COH is higher priority. So 2 nitro benzoic acid, or you can use orthometaparanamine, ortho nitro benzoic acid. Okay, this one almost the same because this is the parent chain. It will be benzoic acid, carbon number 1, carbon number 2, carbon number 3, benzoic acid, and this is 3 nitro benzoic acid, or meta benzoic acid. Okay, so I hope you get the idea. And this one become para nitro benzoic acid. Okay, next. Okay, this one, which one is higher priority? So you need to refer back to the list. Okay, COH always the highest, so that one is easy. Okay, so higher priority is OH. So that one will be named hydroxy. Hydroxy. So this is hydroxy, so it can be phenol. Okay, the parent chain is phenol. And this is attached at carbon number 3, so it can be 3-nitrophenol or meta-nitrophenol. This one is 1, 2, 3, 4. So it can be 4-hydroxy benzoic acid. Okay. And this one, Cl and Br is the same priority because both are hydrogen. But you can give priority to alpha Herbert. Okay, alpha Herbert. So Br is before C. So this one you can name it 1 bromo. If this one is 1 bromo, and this one will be 4. 1 bromo, 4 chloro benzene. But this is same priority. And this one, it can be, there are 2. So 1, 2, 3, 4. 1, 4. Benzene dicarboxylic acid. Okay, I think better if you do the proper name. Okay, para-hydroxy benzoate, 1, 4, 1 bromo, 4 chlorobenzene, or 4 bromo, 1 chloro. I think better you choose this one. Alphabetically, it must more correct. And number 1 is at the front. And this one, benzene dicarboxylic acid. Okay, so let's try. Write the structural formula for 2-chloromethylbenzene. Okay, for you to draw this easier, draw the parent chain first. Okay, the same for this one. Draw the parent chain first. If you have 2-chloromethylbenzene, okay, draw the benzene first. So benzene is like this. Benzene. And you have methyl. Okay, methylbenzene. Methylbenzene is the parent chain. So methylbenzene. And you have carbon number 1. So this is carbon number 2. And you have Cl. So this is the structure for 2-chloromethylbenzene. And for propane, draw propane first. CH3, C, CH3, and attach with phenyl. Okay. Okay, this is carbon number 1. This is carbon number 2, carbon number 3. Propane is the parent chain. So it means that, oh sorry, you need to have double. So that is the phenyl attached to the structure. Okay. So this is the 2-chlorobenzene, and this is this one, CH3, like what I draw earlier. Okay. Okay, for number 2, phenyl is actually benzene as substituent. This happens when alkyl is larger than 6 carbon. Okay, so let's see this one. Okay, for example, this one. How long is this? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so larger than 6. So this one is actually octane. Okay, the parent chain is octane because it is longer than 6 carbon. And benzene ring that attach like this, we call it phenyl. And it is attached at carbon number 2. So this one becomes 2-phenyl. So this is actually 2-phenyl octane, no space, 2-phenyl octane. 2-phenyl octane. But if the chain, the side chain, contain important functional group or unsaturated double bond, triple bond, you can consider the benzene ring as the substituent phenyl or benzene. Okay, for example, this one. Even though only 4 carbon, but this one is having unsaturated bond here. Okay, so this one, 3-phenyl, 1-butene. Okay, 3-phenyl, 1-butene. So the numbering will start from here. 1, 2, 3, 4. Okay, priority is given to the side chain with the higher, with unsaturated or important functional group. And this one, how can we name the structure? Okay, the functional group here is OH. So this whole thing is actually propanol, 2-propanol. Okay, this is 2-propanol. And this is benzene ring, which attached at carbon number 2. This one is 2-phenyl. So it is actually 2-phenyl, 2-propanol. Okay. Okay, let's see it proper. My handwriting is not correct. No, it's not beautiful. So 2-phenyl, 2-propanol. Okay, benzene as substituent. Okay, the same thing you can refer. But this one is benzene. Okay, benzene. Benzene is this part. Okay, bromomethylbenzene, or we can name it benzyl bromide. Benzyl bromide. The same thing for this one. This whole thing is benzyl. So benzyl alcohol or phenyl methanol. But I think this is easier for you to remember. Benzyl bromide, benzyl alcohol. Different with phenyl. Phenyl is like this. Phenyl. This is the bonding. Compared to this one, it have CH2. Another CH2. So that is benzene. That's the difference between benzene and phenyl. Okay, remember that. Okay, I think that is all. So good luck in your studies. Bye.